Okay, I received five, six responses. It looks like most of you have completed Algebra 1, and some of you have not yet finished Algebra 2, and some of you take, geometry. This information help us tailor the session to your level, because accordingly, we can change more or less, our structure. Okay, let's start. During the first 10 to 15 minutes, I will cover the basics of the test. After that, we will spend about 30, 40 minutes going over some examples to give you a sense of my teaching style and how the class usually progress. Let me introduce myself first. You can see me right now, I think, yes. Is there any problem? Okay, so I graduated from university in Turkey, which is 1998. In 1990, so this is like start my career with as teacher. So far it is like 26 years I am in education. I had a lot of positions, but most I teach math. I have been three different countries. This is my third, and then here I start high school here in USA 3 years before. So we will start for fourth year. I cover up all subjects, including Olympiad. Okay, and all high school concept and subjects I cover, from algebra to the AP calculus. And 4 years, I taught algebra college classes like calculus 1, 2, 3 in university, probability and statistics. That's okay. So when it's concerned, we can continue again. So I have two children. So they grow up. One graduate from university, my daughter, and my son now studying data science, computer science, and he will be juniors. Okay, junior this year. Okay, let's start this. What is the ISEE exam? Many of you may already be familiar with it, but just in case you are new, the ISEE is an independent school entrance exam used for admission to private middle and high schools. We are focusing on the upper level, which is for the some elegant high school entry. I will explain the scoring and test scores. This exam offered in 3 testing seasons: winter, spring, and summer. You can register for the tests once per season. Scores are typically available in early January. So you can, take this one twice, 3 times, depends on you, because we suggest our students to take this exam like in the first fall season, like in October or at least in November. And when it is not satisfied, the score, so you have a chance to take this in the second season in December, because we need that score like the beginning of the January first week. At Momentum Learning, we offer not only upper level math, but also upper level English prep, both starting after 2 weeks. The math classes are held every Sunday from 1 to 3 p.m. If you register by August 11th, it was like, okay, so today or yesterday, you will receive a $25 discount. If you register for both English and math together, so you will get an additional $100 off. Our classes are small group lessons with weekly homework and 3 mock exams. The mock tests are completed at home to save class time for instruction, but we will use this mock test to identify the areas where you need improvement. ISEE upper level math section consists of 4 parts. All exam has 4 parts, but the math related one is section 2 and 4. They are like quantitative reasoning and mathematical achievement. Each section has a specific number of questions and time limits. For quantitative reasoning, you will answer 38 questions in 35 minutes. And for mathematics achievements, you will answer 47 questions in 40 minutes. You see the upper level has 2 hours, 50 minutes duration total, and the lower level is 2.5. Quantitative reasoning includes word problems and quantitative comparisons. For word problems, some require no calculation or simple calculators. Quantitative comparisons involve choosing between options like A, B, C, D to compare to quantitatives. Here's like, a question like the first A, it says like A greater or B, and C says they are same, or there is no relation between, these two quantity, like, there are questions that way we will solve. And the achievement one, this aligns with national standards and requires multiple steps to solve problems. We will cover a range of topics, including matrices, probability, and imaginary numbers, as you see. Because I think in our PDF, we have imaginary numbers. Yes, we will talk. I'll focus more on topics not covered in the school and less on topics that students are already familiar with. Okay. For any question about the content or format, feel free to ask. Okay, I will now provide an overview of the ISEE scores. Raw scores are calculated based on the number of the correct answers, with no penalties for incorrect answers or skips. Okay, so you can guess, you can eliminate, the alternatives, so you can get your best guess, like, between two, if you are and didn't decide yet, two, you will eliminate, but you can guess, do not skip any question. Scores range from 760 to 940, used to compare performance across different test versions. Okay, percentile ranking compares your score with other students of the same grade and age. Here, for example, there is a scoring graph. This is a normal distribution, and then there's a 100%. You need to be over 76 percentage. Yeah, you have to be first 25, 26%. Okay, so then this is our goal, to get high scores and then to be eligible for a Elegant High School entrance. Okay. The goal is to achieve percentile ranking 7, 8, 9, which is considered excellent for us. If you have any question, okay, so you can ask them in chat or email us a brief summary of topics starting with complex number. Why we prefer that one? Why we select this complex number? Because you know the other subjects, and then this you may not have an idea about that one. This is like in algebra 2. You are taking this one in algebra 2. This is a little harder than the other topics. Okay, so I can talk about upper level math topics. You can see here. Numbers and operations, algebra, geometry, data analysis. As you see, this data analysis analyzes probability. They are all algebra 2 and also pre-calc classes. Geometry, algebra 1, 2 covered. And also in the next we mentioned, the test not only covers topics from algebra 1 geometry, it may even cover topics from algebra 2 and beyond. Algebra 2, you see we have these topics. And in pre-calc, we have functions, properties, trigonometry, and multiplication. Also, you see all high-level algebra classes included in this exam. Okay, let's start with the complex numbers. Guys, you can ask me any question. Also, you can use chat.
Can you go back to the last slide? We want to see the scope one more time. Thank you.
So, can you say again, please? I couldn't get it.
Yeah, got it. Thank you.
Okay. This is, you see, 8th graders. Okay, so this algebra 2, as I mentioned, and pre-calc. You see, this exam, this upper level, cover algebra 2 and pre-calc classes also. So because of that, yes, you need, there are some harder and some further subjects. So then you have to be ready, Okay, complex numbers. Okay, so okay, complex numbers. There are number set already, yes, real numbers. Okay, let's say basically, let me write, for example, here we have, let's say numbers. We have real numbers. Real numbers, the number systems already, from the beginning. Okay, so all numbers you have studied before, like rational numbers. Okay, under we have rational numbers, like 7 over -5 integers, as you say, rational numbers. Okay, and irrational numbers, what are the irrational numbers? Like root 2, okay. And what else? Pi, for example, and irrational numbers. So when we try to start, talk about these all numbers, like what is irrational, what is rational, so it will take time. Maybe when we study that topics, in a normal class, so we have to go over these all number systems, why it is rational, irrational. Just I want to mention that a number system cover all numbers. Okay, so it is the largest number system, complex numbers. But numbers, you see, so far we get real numbers, the larger one. This real number has rational and irrational numbers. Okay, so these two are subset of real numbers. Now we have additional numbers. So this is called imaginary. Now we will add an imaginary for these numbers. So what is that imaginary? So this is interesting, as you see, why it is imaginary. Okay, so so far you remember, we know that number squares, for example, let me take any number square is positive. Yes, like, 2 square, it is 4, minus 3 square is equal to 9 such that, okay. Is there any number, such that, okay, so whose square is equal to negative? For example, when I have 4 is equal to 2 square, so I can say basically 2 is root 4. Yes, root 4 here. And for 9, I am writing, as you see, root minus 3 square. But at the end, it turns out 3 such that, okay, so then inside always is 9. So just a minute. So I have a mistake. So that is 3. I will say 3. Even it is inside, minus 3 square, but it turns out plus 9. Always in square root, we have a positive number and its square root is equal to, plus 3. Problem is not that one, but here we have a problem, a new number system and minus 1. Okay, we need a number because this number is not real, for example. Okay, so in number system so far we studied it, there's nothing we have like this. A square root of this number is, negative, square root of a negative number is that one. So there is a number like, okay, so we will define that one is an I. So it is square root of -1, or if its square, for example, is equal to -1. This is a new number system. This is the unit of a new number system that is called imaginary unit. Okay. I is imaginary unit. Imaginary unit. My handwriting is not perfect, sorry for that. Okay, unit. Okay, there is no real number that will square to give a -1. Okay, so this is the, impossible, but now we have it. I is an italic, and you see we are using that number is a unit of this imaginary numbers. Okay, so we said I square, by the way, is equal to -1. Let's expand this one because I is square -1, so I square will be like, multiplication of square root -1 and -1. So what is -1? -1 multiplication is, -1. Sorry, that one. Okay, so it is equal to -1. Square is that one. If I take some powers of that unit, for example, what about I cube? I cube is, we multiply I, okay, I square is like -1. If I multiply each side, by I, Okay, so let's say like this simple notation. So that turns out I cube. So then negative one times, I will be what? Negative I. Okay, negative I. Negative. Okay, so we have the powers. You see power I is equal to itself. Yes, you see basically. Let's say I is equal to I, but I square already we know is negative 1. I cube is equal to negative I. And I to the 4, what is I to the 4? I to the 4 is, square of I squared. Okay, so then negative 1 times negative 1. So that will be plus 1. If I go, that powers of this imaginary unit, so we will see something repeating, like 5, fifth power. Fifth power, you see, fourth power times I. And I already know fourth power is 1, 1 times I, so then it is I. And what about, sixth power? Sixth power is only I multiply, fifth power with, a single I. So that turns out 5 plus 1. And okay, it is I, because in the previous step, I to the 5 is I. So I times I. What is I squared? I squared is equal to, or here on the left, is negative 1. And if I continue, so 7th power will be negative I, and 8th power turns out plus 1. And please have a look. For the first 4, power, give us these results. What is I, negative 1, negative I, and plus 1. What about second, 4? Please, you can see, is the same power. You see, it is like I, negative 1, negative I, and yeah, it's the same as I mentioned. So basically, every 4 power of I is the same. It is repeating. Okay. Okay, if we go to the, our first slide, here we can see what is the imaginary unit. The imaginary unit is I, is the number whose square is negative 1. Okay. And then its square is negative 1, or I is equal to square root of negative 1. I is called, imaginary unit. And this one, what is A plus BX? Okay, so, or BI. Okay, here basically, A plus BI. This is our complex numbers. And why? Because that part is called imaginary part. And the other part is real parts, real numbers. Together, it gives us a complex numbers. Do you understand so far? Is there any question, please? Okay, here, for example, let's write that one, 2A plus BI. Okay, so we said that one is real, and this part is imaginary. All numbers are complex number, by the way. But I said, the largest number system. How can it be? For example, it is like 5. Can I say 5 is a complex numbers? Do you have an idea? Can I say yes, please? Also, I can, open this chat. You can write or you can speak, please. 5 can be a real number. This can be, complex number. Why? Because I can write this one like 5 plus, 0i. Here it happens, you see, why? Because A is 5, but B is 0. Okay. And any number here, for example, any real number can be written as a complex number. So complex number is the largest set and cover, all number systems. Okay, so let's have some basic operations in the complex numbers. Okay, so what are they? Addition, subtraction, and multiplication. Okay, here for example, that one. Okay. We have addition of two complex numbers. How can we add, two complex numbers? You remember, binomials, we had two terms of expression, like, every terms differentiated by, plus and minus. And so these are like binomials because we have real and imaginary part. There are two complex numbers in the first addition. How can we add these two? Always you remember when you study, like, equations. Let me take one simple, like 2 plus 3x, let's say our first, and the second, let's say 5 minus 2x. Okay, what is that sum? Likely terms added, there are two likely terms. Two terms are real, as you see. We can add these two, and then it turns out like 7. And the other terms here, they are variables. Okay, 3x minus 2x, negative 2x is equal to x. And then it turns out, you see, 7 plus x. It is same as, in also complex numbers. In the first question, okay, let me do the first one. Or anybody answer this question? What is the, 4 plus 2i plus negative 3 minus 5i? 4, negative 3. Yes, negative 3i. That might be, yeah, okay, very good. Okay, please have a look. Yes, we add the real part. Here we have real. What are these? 4 and negative 3. Yes, these are the real number. 4 negative 3 is 1. And the plus 2i, negative 5i. Okay, so negative 3i. Okay, we are adding real numbers, real part between each other, and the imaginary numbers, imaginary part, we add and subtract that one. Okay, the next one. Okay, like, okay, let's do this one. It is negative 3. Please have a look. We have subtraction. I suggest you, when you have, not simple two numbers, if we have an expression, we subtract first like polynomial or an equation in the first, and we have difference of these two binomial, two trinomial, doesn't matter. So we change this expression to this addition, like negative 3 plus 4i. So this negative, I will multiply any terms in the second part with negative. So let's do like that, negative. So I multiply by negative 1, okay? Or the other way, I can say I take this negative, minus inside. So, okay, so it turns out like plus. So negative 5, okay, and negative 2i. Every single term should be, multiplied by, minus 1 or negative. And now, can you answer? What is that sum? Two complex numbers sum. Okay, what about real numbers? Okay, so sum of real numbers, yes, minus negative 3, negative 5, negative 8. Very good, perfect. And plus 4i, negative 2i is plus 2i. Yes, very good. Okay, so as we said, the third one is similar. What about the fourth one? Okay, so we have a multiplication. How can we multiply? Okay, so this is similar to the, multiplication of binomials. Okay, do you remember, like we give example like, this first question in binomials. Let's do this one same for the multiplication. Let me write, for example, 3. Okay, 3 minus 2i, not my I, let me do this one by x, negative x times, let's say 4 plus 2x. Okay, what is that multiplication? Do you remember? We are using, yes, we are good. 8i squared, so that should, okay. You remember FOIL? Yes, FOIL method. What was FOIL? Yeah, this is first. We multiply first terms into, expression, and the outer and inner and the last terms. Okay, one by one. Okay, first number, 3 times 4, 12. And the second multiplication in outer, so we have 3 and 2x, 6x. And the outer one, 3 times, yes. And the inner one, negative 4 and negative x times 4, negative x. And the last terms, negative x times plus 2x, negative, okay, negative 2x squared. Okay, likely terms should be added. We have 12, it is only a constant number. And 6x minus x, 5x, and negative 2x squared. Okay, there is no likely terms to have the further operation. So then we have that one. The result is this way. Okay, we apply this one to the same as, on the complex numbers. Okay, let me, clean this one. Okay, let's start our complex number multiplication. Okay, here we have a question, but it says there's a definition for complex conjugate. We have a real numbers, okay, a plus b. Okay, the a and b are real numbers, but a plus bi, when we add, I, so that turns out they're complex number. And these two are conjugate of each other. Between terms, we have reverse operation only, okay? A plus bi, a minus bi. Why do we need this one? Okay, why, people, talk about that conjugate, complex conjugate? Please pay attention. If we have two complex conjugate, okay, here, let me do here simply. Okay, already we have one. Okay, negative 2 plus 3i. Because when we multiply conjugate and, conjugate and the original complex number, so something happened. Okay, let's see what will happen. This is negative 2 plus, the other is negative 2 minus 3i. They are conjugate of each other. What is multiplication? Already we know FOIL method. Negative 3 times negative 3. Outer negative 2 times negative 3, so this is plus 6i. Inner one plus 3i negative 2, negative 6i. And the last term multiplication is negative 9i squared. Okay, so for here we have this one that is very important. So we cancel some terms here. What is happening? We cancel only, or after this multiplication, only we have these numbers, the imaginary middle ones. It comes from outer multiplication. Let me show. You see this outer multiplication and inner multiplication, because in both we have real and, complete imaginary part multiplication in both. So the results will be, an imaginary. But as you see, they simplify, they cancel out each other. And then what happened? I have only, because the I squared is real number, which is equal to -1, and 4 plus 9 is 13. As you see, our complex numbers, we multiply two complex number, but the result is real number. Okay, so when I try to, get rid of a complex denominator, or when I multiply, or when I simplify a complex number from anywhere, it can be in numerator or denominator, I will multiply this number with its conjugate, multiplication. Okay, let's read the question. Which of the following complex number is equal to, yes, -I minus 1 over -I plus I plus 1. Before that one, also I want to remind you, but we need that conjugate also for the radical numbers. We already did that one. For example, we have 3 over, do you remember 2 plus root 2, for example? I want to cancel, or I want to, simplify denominator from a radical expression. I don't want to see radical expression, so we multiply by its conjugate, root 2. Okay, so conjugate of, always between terms we have reverse sign. Okay, let's turn back to the, again, complex, because I am not using time efficiently. We have a lot of questions. I need to give some details at the beginning. Why? Because this is first time you will take that one in Algebra 2. I didn't start, or I didn't solve just question. We need an introduction. But when we are studying that one full class, so that should be step by step, all details, because we have a limited time right now. Okay. I want to change this one to do what? Real number. I want to change denominator to the real number. Okay, so I will use a conjugate. What is the conjugate of I plus 1? Okay, very good. So we multiply by I minus 1. Okay, we multiply, numerator and denominator. Always please pay attention. You have I minus 1 over I plus 1. Have a look. I can multiply, I can multiply and divide an expression, numerator and denominator, with the same number except 0. Okay, why? Because multiply by 5 and dividing by 5 means 1. Okay, multiply by, 1 million over 1 million is the 1. So basically, we multiply expression by 1. Of course, doesn't change. Nothing will change. Okay, so then we will do the same. I will multiply by, -1, I plus 1. Okay, let's multiply numerator and denominator. So numerator, let's write the longer way. It turns out like that. I minus 1. We multiply, denominator with its conjugate, I minus 1. And this numerator is like, square of I minus 1, but we can use, the inner FOIL method, I times I. Here, please pay attention. The place of real and imaginary part is different. Doesn't matter. We have the same operation, same steps. Okay, I times I, first terms, it is I square. You see, it exists at the first. And the other one, I times -1, and the inner one, -I, and the, last terms is +1, divided by conjugate. Okay, I squared conjugate multiplication. Okay, so I squared -I plus I. You see directly, we can see that simplification, and the other one, other multiplication, -1. So these cancel, -I plus I. And the numerator turns out, I square is, directly you can put this one is equal to -1. So this -1 and +1 cancel. And you see we have, as a result, in numerator, I have only -2i. In denominator, I have, okay, what about this? This again, -1. -1, -2, -1 is -2. What's -2? So I can divide, you see here, they are in multiplication form. Okay, it is anything. It can be X, Y, Z, or any number in product form. You see, then I can simplify, these numbers, -2 and -2, and that is equal to I. So it takes time. Why? Because we have a lot of operations here, but we multiply first by a complex conjugate, and then after this multiplication one by one, it takes time, and then it turns out that I is a little longer one. Okay. Here, which of the following is equal to sum of the complex numbers? Okay, so this is similar to the other question, because we will talk about also trigonometry, but yeah, we have to, I want to skip this question. Basically, we have the square root of 2 plus I and 2 minus I, and then after we add, because sum it says, we will add two complex numbers. This question seems to be a little different. Just we can talk about this one before trigonometry. We can solve some question from trigonometry. Okay. Okay, so here, which of the following equations has the root of these two plus 2i negative 2i? What is the mean of root, for example? So I have like an expression, let's say x plus 2. This is an equation. Equation means, equal to 0. What is the root of this equation? What is the root of this equation? X is equal to negative 2. Why? Because when I substitute, instead of that variable, when I substitute negative 2, that, it gives us 0. It is called zeros of the equation, zeros of the, so it is called like a 0. So the substitution gives us a 0. For example, negative 2 is root of that one. I can write, x minus root, for example. Let's say root equal to 0. For example, if root is like here 2, I can write x minus 2 is equal to 0. The expression should be like that, x minus 2 equal to 0, because when you substitute again that 2, 2 minus 2 is equal to 0. And so I can do this one for the other part, like first root that one, x minus 2 times, okay. So I need another part. I have the second part whose root is 2i. X minus 2i, I can say. Why? Because again, the same reason, when I substitute 2i instead of x in the second part, so then it is 0. So it works, as you see. And for the third one, we have, because 3 roots, for the third linear, I can put, again, 2x minus, but root is negative 2i. Be careful about this negative. And you see x minus root. We are writing x minus root. Root r by 2 and 2i negative 2i. Okay, so just we will collect this all operation. X minus 2i times x plus 2i equal to 0. And we can multiply. You see the expression when we have this alternative. In alternatives, I don't have any I. There is no complex imaginary part. So because of that, I want to multiply these two. And what are they? You said that one, perfect. Why? What are they? They are conjugate. You see, one of them x minus, the other x plus 2. So then it will be like that. Quickly, I want to do this one. X square minus 2i squared. It is square difference, or the longer way you can do this one. And this is x minus 2 times x squared minus 4i squared. Okay, so x minus 2, be careful. Again, what? Why? Because here negative, this is negative 1. I squared is negative 1. So negative 1 times 4 is plus. So then it is x squared plus 4. X minus 2, x squared plus 4. The answer is A. You might have, basic mistakes, plus minus. That is understandable the first time. we have the critical one. You see those questions. We have to be careful about those negative uh, multiplications. Now trigonometry, we have few minutes. Okay, so trigonometry, maybe you know that one. This is a Greek word. Trigonon is triangle, metria is measure. Okay, we have these, ratio, these relation. When we have a right triangle, in right triangle, we have these terms. One of them is adjacent, the other is opposite. Why adjacent? Adjacent for this angle, of course. Adjacent is neighbor one, okay? The neighbor. There are two right sides. One of them is called adjacent, the other is opposite, always for an angle, for a right triangle. Always we have adjacent opposite, but the name depends, the angle. For this angle, opposite, of course, you see, opposite of this angle is that one. Okay, adjacent here, this one. Okay, so then, if we understand, what is adjacent, what is opposite, it's okay. The hypotenuse is the opposite of right angle. Okay, so here we have right angle, 90 degrees. Opposite of the largest side in right triangle, always hypotenuse. It is called hypotenuse. Okay, according to, yes, we have some ratio related to these, values. What are they? Sine theta. Sine theta is equal to always opposite over hypotenuse. It is also called, rise over run, or, the other one. But better, learn this one in academically. This is adjacent over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, always. Okay, for example, one basic question. Okay, let's say this is 30 degrees. Okay, that one is 2, that one is 1. Let's say this is root 3. Yeah, this is if we calculate that one. What about here? Sine 30. Sine is, you see what was sine? Sine is opposite, okay, opposite. Opposite of 30 is 1, okay, over hypotenuse. Hypotenuse is, opposite of always the 90 degrees. It is 2, 1 over 2. Okay, like this, for example, tangent theta is opposite over adjacent. For 30 again, opposite is 1 over adjacent root 3. Okay, now, what about this question? Okay, I will normally, that this is a trial lesson, and then this will take, between 2 and 3. Okay, let me do, some question, a few at least from trigonometry, then after, let's say goodbye. Okay, trigonometry, but please have a look. The question, let's read the question. Always, the understanding and reading a question is the half of solution. Okay, so what is the given, what is required? Okay, first, there is a right triangle given. Okay, it is not, declared as right, but from figure we can understand. The length of D is given. The length of that one is given 4 inch. Given is that one 4. And angle is here, please have a look. Question, what is the value of DF? DF is hypotenuse. Question is that one. Find this. Please have a look. Sine, cosine, tangent. Okay, so I have an angle. I have, one side given. It is neighbor, adjacent, and we have an hypotenuse, which is the question. Okay, so which function we have to use? Functions, they are actually trigonometric functions, but of course we didn't discuss what is function or, but they are sine, cosine, tangent, cotangent. Also, they are called trigonometric functions. Okay, which relation like function, okay, is concerned for this question? Cosine. Okay, perfect. Why? Because angle is 64. Okay, for this angle, given is here. It is adjacent. Adjacent given, hypotenuse asked. So adjacent and hypotenuse means cosine. Perfect. According to that angle 64. So cosine 64 degree is equal to adjacent 4 inch over hypotenuse, df. Okay, so we need to find, df. Here you can directly, change, if we have, a over b is equal to c over d, okay, you can change this to number having different positions. Okay, in equation, you see we have this one. This is numerator and this is denominator. On the left, we have numerator. The other side, we have denominator. So I can change their position. Nothing will change. For example, D will be here and B stay. C and A will come to, instead of A. So we have the same expression, doesn't change. We didn't change anything. Okay, so this is a way you can take df to the other side as a numerator, and you can take, why? Because here actually it is in numerator. Why? Because already we have one, but it is not written, invisible. So cosine 64 in numerator. Okay, 4 over cosine in numerator. Now it will be in denominator. So it is like cosine 64. This is an answer. Or you can do, the longer way. Cosine 64 is equal to 4 over df. But you see the question, remember we have number of question 40, but we have 45 minutes. We have like 37 question. We have what? 35. So almost we have a little more than 1 minute for each question. Because of that, in this problem solving, you need to know question, how to solve question, but also you need to solve in 1 minute. Yeah, you are competing with, like SAT exams. Time matters, very, very important. Okay, so for some question, of course, it will be like 2 minutes, but for some like this, you will solve in 20 seconds, for example. Okay, so you will arrange that one. Okay, so you have, what is the longer way? The standard way. I want to cancel df from the right side. Df, we multiply each side by the length of df. Okay. For on the left, it is like the E is given like this symbol. It means, this segment. But for the length or magnitude, we can use different way, like DE. Okay, here in. But shortly, we can also use sometimes like DE. Okay, because of that, I didn't put any symbol or, sign. And these cancel. You see, these are canceled, this one. And then I have on the left cosine. But I need df. I want to isolate, df. So now I have to divide each side by cosine 64 because always we have to use opposite or reverse operations. If I have multiplication, cosine 64 in multiplication form, what is reverse operation? Division. I need to divide by cosine 64 to simplify expression. Now, yes, these cancel, but cosine 64 is not zero. We can cancel. This is an exception. We have to be careful. We can't divide this side by zero, yes, df is equal to 4 over cosine 64 as we get this one, in the first. The answer is D. There are similar questions. Okay. Here it is also something different. Okay, so let's solve this one because it is also tangent is concerned here. Okay, please have a look. Why tangent we are? Directly you check, the alternative. So the answer is related to tangent. Why it is related to tangent? Because question, find IH. Yes, IH here. IH. IH is adjacent up to, 34 degree. And what is given? Opposite, which is 2. Opposite given. Question is adjacent. And so adjacent and opposite related to, tangent. So then you can say what is tangent 34, is equal to opposite over, adjacent. Adjacent is a question. You can put like X question mark, okay? Or what is it? Like it is given IH. IH, okay, here. Okay, directly I want to exchange, on the Left side we have a number tangent 34, and the other side we have denominator. So 2 can be exchanged quickly. Then IH is equal to 2 over tangent 34. 2 over tangent 34. So this is like B. Mhm. We have any question, please, about that one? Okay, sorry, I didn't check your message, but you have an answer, Jay. Yeah, okay, thank you. Mhm. Okay, that's all this. This might be one of the last question. Okay, that's all this question. After pandemic for like two years, so we didn't have any online course. So then the flow of the course sometimes, stop, not smoothly goes. Yeah, we didn't have this online courses long time. So, but in a few classes, so I think so we will get this transition quickly. Okay, so then what is that question? Again, please have a look. Always we have to read question and what is given, what is asked, request or. Okay, so we have length TU. TU is here given. Angle is given here. Angle and that one, you see the position. So for that angle, this is adjacent. The question is SU. SU. Here, this, let me say X. X is hypotenuse. Okay, this is hypotenuse. So adjacent and hypotenuse is, what is adjacent hypotenuse? Okay, it is cosine, yes. So cosine 10. Cosine 10 is equal to adjacent over hypotenuse, let's say X. Again, we have, exchange this position cosine 10. Okay, here also we have, normally we will talk about that nets. This is like a game. Okay, so let me see. Okay, here, for example, this is two-dimensional. When we, let's say, when we open, a cube, so there will be a two-dimensional figure. Normally, what is cube, what is triangular prism, or this rectangular prism, pentagonal prism, they are all three-dimensional. Okay, so they have like base and altitude. According to the base laws will be named like, this cube, has a base as a square, so that is called cube. Triangular base, and when we open, these bases are given, and when this is the open, when you fold up those figure, on nets, you will get again this polyhedra. You will get this solid. Okay, so just a minute. Okay, you can see right. Okay. Let's go. For example, this is question. There are some questions similar to this one here in this ISEE exam. This is like, let's say, they are like, logic questions. They measure your visual skills, your imagination. Can you imagine, for example, that one? Okay, so you can't use a cube. You can write, the name A, B, C, then you open. Just you will imagine, and then you will decide. Like, okay, let's solve this question. Okay, do you have an idea for that one? Okay, one answer is D, says D, or B. Okay, perfect, Vincent. Option C, yes. They are all similar, but there are some, uh, D also. Yes, there are different answers. Okay, it seems to me, B, I am not perfect, again, to be honest, for these imaginary problems. type is, sorry, it is C says. Okay. When we open this one, for example, when we expand B, C, B and C position, you see it is, yeah. So when we have a look, this part is okay. And A is okay, like this. And when we, fold up, the position of A and C will be like this. Okay, you can imagine right now, we fold this, this picture to make a cube. A and C. Okay, so okay, YC, we fold up, B will be that one, AB. But here, for example, A and B position, because of that, here it is not true, I think, because B is, vertical, B is horizontal, but they are almost the same position, A, B, B, A, whatever. So C is not true. Why not D or D? Okay, so you have an answer. Okay, it seems to be B, but okay, so let's see the last one, D. A and B. Again, the position of A and B. Please have a look. B and A here, for example. Okay, so then, okay, the others is okay, but you have to check. Not only they will be like, adjacent, they will be a neighbor surface, but when it happens, what about their, they are like, horizontal, they are, portal. Okay, so you have to check also their positions, not only, their place, let's say. Okay, it seems to me like, B. Okay, what about this question? And I think we can finish that one. This might be the last one. Mhm, mhm. Yes, you have to see these all positions, and then, you have to check. What about D, for example? Can it be right answer? When it close up, it is like, you can figure like that. You can draw a cube. Yes, as I mentioned, I am perfect in, drawing, but okay, I will try again. For example, you can draw a cube and then you can try for those questions. This is only your, imagination. Okay, for the last one, for example, let's try. This will be when we close up. So that will be that side on the left. This will be one dot. And that base one, the other, so that will be two. Uh, this will be four. But I don't need this one. Actually, we have to see the position of these four. Okay, we need that four too. You are right. So what about four? So when we close, So 4 will be here. Okay. Right now, the position of 1 and 4. 1 and 4, it's okay. Yes, you see, yeah, that can be because they are now neighbor. What about 3 such? Okay, so 3 comes, when we fold up, that 3 will be this up, I mean here such that, okay, so this service will be like 3, and this will be like, when we close it, it is like 3 dots. And the position, okay, so here on the picture we can do position of 3 will be here, it is like that, like this. Okay, here 1 3, when we close that one fold, so this 3, and you see this will be like, there are 2 ways, one end between 3, it can be here, this is the true one because here in this picture, or in some question, in some way it is like that. Okay, so the position of these 1 and 3. Okay, so in this picture, in the given one here, as I see, it is like the first one. And then when we close up or fold up the, that last one, we have the similar, same. That, yeah, okay, so we have to see that one. There are, you need time for this question. You need some practice. And at the end, but they are fun actually, like a game. So you can solve this and then you can check your intelligence, like visual intelligence or, your imagination. Okay, here. Okay, almost, yeah, everybody's here. Okay, guys, so this is, a trial lesson, and then after 2 weeks, so question, subject by subject, so we will start, and then it will go fast, 2 hours. So there will be some mock exams, there will be homeworks, and then, okay, so then I hope you will be ready for the ISEE exam, and then, you will get good scores. Okay, thank you very much for your patience. Okay, so as I mentioned, this is first hour, just you do not know the complex numbers, so this is not way we have to talk about all details and then after. But this limited time, in this limited time, I try to give you this, what is complex numbers and basic operations. And then a little, we talk about trigonometry. Thank you very much. Have a great weekend.
I have a question.
Yes.
Are you just gonna teach geometry? Are you just gonna teach trigonometry?
Okay, let me close this share. Okay, can you say again? I couldn't get it. Geometry, yes, we have a geometry, of course.
So my son has not learned the trigonometry. So we wonder during your class, if we sign up, are you going to teach that from the beginning, or we have to learn something ourselves before taking your lesson? Because you just gave a lot of examples just now. Since he didn't learn it, he couldn't follow you. So we just want to know, if we sign up for your lesson, what kind of prep we need to do before we can even take this lesson from you.
Okay. I got it.
So do we need to self-learn the trigonometry before we take your lesson, or you're going to teach from the beginning of the trigonometry?
Yeah, from the beginning of trigonometry, already you do not know this trigonometry. It's just we mentioned about this ratio, what is, sine, cosine, and the tangent. Trigonometry is a large subject. This is a pre-cal dual second semester. So in details, people are studying. But all subjects we will study according to that exam. I mean, what type of questions we have, what do we need? Sometimes, we tail the subject, and then we will learn, the one related to this exam.
Okay. Basically, you teach that for those harder topic, because he has not taken those lessons yet. Okay, good to know. Because otherwise, if you just focus on solving the problems, but he doesn't know the basics, then he was totally lost for 10
Yeah,
minutes.
yeah, I am, we are not a course, we are not experienced that course, like a course teacher. We are normally, yes, in class we are giving, because of that, yes, because of that tradition or this way, always I will give, basics of the subject first of all. Okay, so I will give all details, then after we will start, problem solving.
Sounds great. Thank you so much. That
Thank
sounds
you.
good.
Thank you very
Thank
much.
you. Bye.
Thank
Thank
you.
you.
Bye-bye.
Bye. Have a great day.